Hi viewers, today I will teach you the operation of matrices. This is the second class of matrices and now हम discuss करेंगे about the operation of matrices. Operation on matrices means the addition, subtraction, scalar multiplication and the product of matrices. How these operations occurs in matrices. The first is the addition of matrices. For addition of two matrices, अगर हम टू मैट्रिक्स को ऐड करना चाहते द फर्स्ट कंडीशन फॉर एडिशन फॉर टू मैट्रिसेस इज द ऑर्डर ऑफ द टू मैट्रिक्स मस्ट बी सेम इफ द टू मैट्रिसेस आर नॉट कंपेरेबल मैट्रिसेस मीन्स द मैट्रिसेस ऑफ सेम ऑर्डर आर सेड टू बी कंपेरेबल जब टू मैट्रिसेस का ऑर्डर सेम हो जाता है तो हम कहते हैं कि तो टू मैट्रिसेस कंपेरेबल सो द टू कंपेरेबल मैट्रिसेस कैन बी एडेड अगर टू मैट्रिसेस कंपेरेबल नहीं होंगे तो ऐड नहीं कर सकते सो द फर्स्ट कंडीशन फॉर एडिशन ऑफ टू मैट्रिसेस इज द टू मैट्रिसेस मस्ट बी सेम ऑर्डर इफ द ऑर्डर ऑफ द टू मैट्रिसेस आर सेम देन दे कैन बी एडेड सो हियर इज A is a matrix whose element is Aij and the order is m cross n. In the first class I have already said the notation of a matrix. So A is a matrix of Aij of order m cross n. B is a matrix Bij of order m cross n. So here the two matrices have same order. इधर जो टू मैट्रिक्स हम लिए हैं वो टू मैट्रिक्स का ऑर्डर सेम है तो हाउ कैन वी ऐड नाउ सपोज C is a matrix which is A plus B and A plus B is A matrix is Aij m cross n plus Bij m cross n. So this is the addition of two matrices. Now these two matrices have same order. ये जो two matrices है इसका order same है तो we can add. How can we add? Now the addition of two matrices is Aij plus Bij of order m cross n. So if the two matrices are of same order then they can be added by adding their corresponding elements. Their corresponding elements means Aij with Bij means A11 with B11, A12 with B12, A13 with B13. So if the order of two matrices are same then the two matrices can be added by adding their corresponding elements. And the interesting thing is the sum of two matrices. Now here C is A plus B. Now this is the sum matrix. Now this matrix has order m cross n. So if two matrices of same order, suppose m cross n are added, then the sum matrix has order also m cross n. That means the two matrix and the sum matrix has the same order. जब हम टू मैट्रिक्स का ऐड करते हैं तो जो नया मैट्रिक्स आता है सम मैट्रिक्स रिजल्टेंट मैट्रिक्स उसका भी ऑर्डर इसका भी ऑर्डर m क्रॉस n ही होता है उसका ऑर्डर भी चेंज नहीं होता है सो दिस इज द एडिशन ऑफ टू मैट्रिसेस नाउ इज सबट्रैक्शन ऑफ टू मैट्रिसेस सो टू मैट्रिसेस कैन बी एडेड if they are of same order. Similarly like addition subtraction is the same process as if addition. Subtraction भी addition जैसा है simply it is the addition of a negative of a vector. We know a minus b means a plus minus b, so subtraction means addition of a negative. So one matrix can be subtracted from other matrix. That means subtraction of matrices can possible when the two matrices are of same order. First condition for addition and subtraction is that the two matrices must be of same order. अगर two matrices का order समान नहीं होगा addition subtraction नहीं हो सकता. So if two matrices are same order then subtraction can possible. And how can we subtract a matrix from another? By simply subtracting the corresponding element like addition. Addition में हम जैसे कर रहे थे कि corresponding elements ऐड कर रहे थे subtraction में corresponding elements subtract करेंगे तो addition और subtraction के लिए प्रोसेस क्या है टू मैट्रिसेस का ऑर्डर समान होगा और करस्पॉन्डिंग एलिमेंट्स ऐड होंगे या सब्ट्रैक्ट होंगे सो लेट अस टेक एन एग्जांपल A is a matrix 1 3 5 2 0 6 of order 2 cross 3 B is a matrix 2 minus 1 0 minus 1 4 1 so these two matrices have same order A has order 2 cross 3 B has order 2 cross 3 these two matrices have same order now we want to add these two matrices that means we want to find A plus B now A plus B is A matrix plus B matrix so the order is the same how can you add the two matrices can be added by adding their corresponding elements. Corresponding elements means A11 with B11. That means here the two matrices can be added by 1 plus 2. Then second element 3 plus minus 1. That means 3 minus 1. 5 with 0. 5 plus 0. Next is 2 with minus 1. 2 plus minus 1 means 2 minus 1. 0 plus 4 and 6 plus 1. So this is 1 plus 2, 3, 3 minus 1, 2, 5 plus 0 is 5, 2 minus 1 is 1, is 4 is 7. So this matrix is also of order 2 plus 3. A का ऑर्डर 2 plus 3, B का ऑर्डर 2 plus 3. जब हम ऐड कर दिए तो टू मैट्रिक्स को ऐड कैसे करते हैं, कॉरेस्पॉन्डिंग एलिमेंट्स को ऐड कर दिए. फर्स्ट A11 के साथ 1 1, 2 2, 1 2 के साथ 1 2. कॉरेस्पॉन्डिंग एलिमेंट को जैसे ऐड कर दिए तो न्यू मैट्रिक्स हमको मिल गया. ये जो न्यू मैट्रिक्स आ गया ये सब मैट्रिक्स. दिस इज A plus B. नाउ लुक एट हियर, द ऑर्डर ऑफ A plus B इज 2 plus 3. A का ऑर्डर 2 plus 3, B का ऑर्डर 2 plus 3, A plus B का ऑर्डर भी 2 plus 3 एंड A minus B का ऑर्डर भी 2 plus 3 होगा. एडिशन सब्ट्रैक्शन में जो नया मैट्रिक्स आता है उसका ऑर्डर चेंज नहीं होता है. नाउ इज A minus B. हियर A इज दिस मैट्रिक्स, B इज दिस मैट्रिक्स एंड सब्ट्रैक्शन. सब्ट्रैक्शन मीन्स वी हैव टू सब्ट्रैक्ट द करेस्पॉन्डिंग एलिमेंट्स. करेस्पॉन्डिंग एलिमेंट्स को सब्ट्रैक्ट करना पड़ेगा. कैसे? 1 minus 2, 3 minus minus 1 means 3 plus 1, 5 minus 0, 2 minus minus 1, this is 2 plus 1, 0 minus 4, 6 minus 1, and the matrix is 1 minus 2 is minus 1, 3 plus 1 is 4, 5 minus 0 is 5, 2 plus 1 is 3, 0 minus 4 is 5. So this is a matrix of order 2 plus 3, and in this way we can find A plus B, A minus B. So this is the addition and subtraction of two matrices. Now another operation is the scalar multiplication with a matrix. How can we multiply a scalar? The scalar means real number or complex number. How can we multiply a number with a matrix? Actually matrix is an arrangement of numbers. Matrix is arrangement of numbers. And how can we multiply one number, one scalar with arrangement of numbers? How can we multiply a scalar with a matrix? So dear students, when a scalar is multiplied with a matrix, then the scalar is multiplied with every elements of that matrix. जब हम एक स्केलर को मल्टीप्लाई करेंगे, एक नंबर, स्केलर मीन्स नंबर, रियल नंबर हो सकता है, कॉम्प्लेक्स नंबर भी हो सकता है. जब मैट्रिक्स के साथ मल्टीप्लाई करेंगे, मैट्रिक्स क्या है? अरेंजमेंट ऑफ नंबर्स. तो अरेंजमेंट ऑफ नंबर के साथ नंबर मल्टीप्लाई करेंगे. जब एक कंस्टेंट एक मैट्रिक्स पे मल्टीप्लाई होगा तो दैट नंबर विल बी मल्टीप्लाइड विथ एवरी एलिमेंट ऑफ दैट मैट्रिक्स. तो ये नंबर को हम हर एलिमेंट के साथ मल्टीप्लाई करेंगे. तो देखो, suppose A is a matrix Aij of order m cross n and K is any scalar, K be any scalar. Scalar means real number or complex number. Now K into A means a scalar into the matrix is K into, here is Aij of order m cross n. When a constant is multiplied with a matrix, then that constant is multiplied with every elements of that matrix. That means this is K into Aij of order m cross n. Again, also after multiplying a constant with the matrix, the order of the new matrix remains same. अगर तुम constant multiply करोगे तो जो new matrix आएगा उसका भी order change नहीं होगा. The order of new matrix is same as the order of A. So now K into A is this much. Also dear students, K into A is equal to A into K. Constant into matrix is equal to matrix into constant. So एक बात याद रखना, when you are multiplying a scalar with a matrix, तो तुम क्या करोगे? You have to multiply that scalar with all elements. तो इस scalar को हर element के साथ multiply कर देना. So look at an example here. Suppose A is a matrix 2 3 1 1 4 5 of order 2 plus 3. Now 5 is a scalar. Now I want to find 5A. 5 is a scalar. So what will be the value of 5A? 5 is multiplied with the matrix. How can we multiply? 5 into 2 3 1 1 4 5. सो स्केलर इनटू मैट्रिक्स मीन्स ये स्केलर को हमें हर एलिमेंट के साथ मल्टीप्लाई करेंगे. दिस स्केलर विल बी मल्टीप्लाइड विथ एवरी एलिमेंट ऑफ द मैट्रिक्स. दैट मीन्स दिस इज 5 into 10. 5 3 जा 15. 5 into 1 5. 5 1 जा 5. 5 4 जा 20 and 5 5 जा 25. And the order of this matrix is 2 plus 3. In this way we can multiply a scalar with a matrix. Scalar is multiplied with a matrix means scalar is to be multiplied with every elements of that matrix and the order remains same. Now is the properties of matrix addition. So the first property is let A is a matrix of Aij of order m cross n, B is a matrix Bij of order m cross n, C is a matrix of order Cij of order m cross n. Suppose A, B, C are three matrices of same order. तो here A, B, C three matrix का order same है. कितना? m cross n. Now the first property is addition of matrices is commutative. Matrix addition is commutative. How? What is commutative? A plus B is equal to B plus A. The value of A plus B is same as B plus A. This is commutative property of matrix addition. Second is addition of matrices is associative. This matrix addition also obeys the associative property, means A plus B plus C is equal to A plus B plus C. This is associative property. Next is existence of additive identity element. Additive identity. You know, dear students, 5 plus 0 is 5. Adding 0, the value does not change. This 0 is identity element. Like numbers, also there is a additive identity matrix in case of matrix operation. How? A plus null matrix. A is a matrix Aij of order m cross n. And suppose this is 0 matrix, null matrix is, this is the null matrix of order m cross n. That means order of A and order of 0 are same. Only thing is in null matrix, every elements are 0. So A plus 0 is equal to 0 plus A is equal to A. That means if you are a null matrix with a new matrix gives that matrix. So अगर तुम नॉल मैट्रिक्स को ए मैट्रिक्स के साथ ऐड करेंगे तो रिजल्ट ए मैट्रिक्स होगा. तो मैट्रिक्स का वैल्यू चेंज नहीं होगा. तो ये मैट्रिक्स को ऐड करने के बाद ए का वैल्यू चेंज नहीं हुआ. सो दिस इज द आइडेंटिटी एलिमेंट. दिस इज एडिटिव आइडेंटिटी एलिमेंट. After adding this matrix, the value doesn't change. So this matrix also exists. That's why existence of additive identity. Next is existence of additive inverse. Additive inverse, dear students, 5 plus minus 5 is 0. That minus 5 is additive inverse of 5. That is in case of numbers. Same in case of matrix operation. Suppose A is a matrix. Then we can find another matrix minus A. And A plus minus A is null matrix. Also this is same as minus A plus A. A plus minus A 0 matrix A. So this minus A matrix is known as additive inverse, and this also exists in matrix, and that's why existence of additive inverse ये भी होता है, and this is known as additive inverse. And the last property of matrix addition is the cancellation law. You know it very well. How? Suppose A, B, C are three matrices given. If A plus B is equal to A plus C, so A is cancelled on both sides, and that remains B is equal to C. Here is B plus A is equal to C plus A. A is cancelled on both sides, B is equal to C. But what happens? Here A is cancelled on both sides, but here A is left to B and C. Here A is right to B and C. That's why this is a left cancellation law, this is a right cancellation law. These are the properties of matrix addition. Now is the properties of scalar multiplication. Suppose A is a matrix Aij of order m cross n, B is a matrix Bij of order m cross n. Now K and L are scalars, two constants. The properties are K into A plus B is equal to K into A plus K into B. Now the scalar is multiplied to the left of sum, left of addition. K multiply किया है left side पे. Now here is same property, but K is multiplied right to the matrix. Here K is left to matrix, K is right to matrix. A plus B into K is AK. AK is KA. KA plus KB. Next is K plus L into A. these two are scalars. A is a matrix. This is Ka plus La. Now A into K plus L is Ka plus La. Here is K into La is equal to L into Ka is equal to Kl into A. Minus K into A is minus of Ka is equal to K into minus A. 1 into A is A. If you multiply a scalar 1 with a matrix, then it's the matrix A. The last one is minus 1 into A is minus A. So minus 1 is scalar. If you multiply this minus A with matrix, then this minus 1 is multiplied with every element. So this is minus A, and this minus A is negative of A. So in order to find the negative of a matrix, you have to multiply minus 1 to every elements of that matrix. Now A is given 3, 1, 5, minus 4, a matrix, and negative of A is minus A. Minus A means you have to multiply minus 1 with all elements. This is minus 3, minus 1, minus 5, minus 1 into minus 4 is 4. So this is the negative of matrix A. Another question is A is 8, 0, 4, minus 2, 3, 6 is a matrix of order 3 cross 2. So this is of order 3 cross 2. B is a matrix 2 minus 2, 4, 2, minus 5, 1. This is of order 3 cross 2. Now the question is, if 2a plus 3x is equal to 5b, then find the value of x matrix. How can you find the matrix x? Now given 2a plus 3x is equal to 5b. So 3x is equal to 5b minus 2a. 5 into b is this matrix, minus 2 into A is this matrix. So we put B and A here, and now 3x is equal to 5 into this. When a scalar is multiplied in a matrix, we have to multiply that scalar with all elements of the matrix. जब 5 को मल्टीप्लाई करेंगे हर एलिमेंट के साथ मल्टीप्लाई करेंगे, तो 3x is equal to 5 into 2, 10, 5 into minus 2, minus 10, 5 4 जा 20, 5 2 जा 10, 5 5 minus 4 जा minus 25, 5 1 जा 5, minus 2 into this matrix. So 2 is to be multiplied with every element of this matrix. 2 को हम every element के साथ मल्टीप्लाई करेंगे, तो 2 के हर एलिमेंट के साथ मल्टीप्लाई करने के बाद ये मैट्रिक्स आया. So 3x is equal to this minus this, and subtraction 10 minus 16 is minus 6, minus 10 minus 0 is minus 10. So subtraction करने के बाद हमको ये मैट्रिक्स मिला. This is the subtraction matrix. Now 3x is equal to this matrix. तो x is equal to, we have to divide 3. So x is equal to 3 divide करेंगे means x is equal to 1 by 3 into this. 3 divide करेंगे 1 by 3 into this. So 1 by 3 into this matrix means we have to multiply this scalar 1 by 3 to every elements. That means 1 by 3 into minus 6 means हमको 3 डिवाइड करना है, means 3 को हर एलिमेंट के साथ डिवाइड करना है. So you have to divide the 3 with every element. Minus 6 by 3, minus 2, minus 10 by 3, 12 by 3 is 4, 14 by 3, minus 31 by 3, minus 7 by 3. So this is the value of matrix X. Now is the multiplication of two matrices. How can we multiply two matrices? What is the condition for product of two matrices? अब तो हम एडिशन और सब्ट्रैक्शन पढ़ चुके हैं, अब पढ़ेंगे मल्टीप्लिकेशन. टू मैट्रिक्स का मल्टीप्लिकेशन कैसे करेंगे? व्हाट इज द कंडीशन टू फॉर द प्रोडक्ट ऑफ टू मैट्रिसेस? टू मैट्रिसेस के लिए कंडीशन क्या है? एडिशन और सब्ट्रैक्शन के लिए कंडीशन था तो टू मैट्रिसेस कैन बी एडेड और सब्ट्रैक्टेड इफ दे आर ऑफ सेम ऑर्डर. ऑर्डर सेम हो जाएगा तो एडिशन सब्ट्रैक्शन हो सकता है. बट फॉर मल्टीप्लिकेशन व्हाट हैपेंस? सपोज A इज ए मैट्रिक्स ऑफ ऑर्डर m क्रॉस n whose element is aij. B is a matrix of order n cross p, of order n cross p, and the element is bjk. Now C is suppose the matrix A into B. A का ऑर्डर m क्रॉस n है, B का ऑर्डर n क्रॉस p है. सपोज A and B, when we multiply these two, suppose the matrix is C. Now look at here, the order of m cross n, the order of A is m cross n and the order of B is n cross p. Just mark one thing here. The number of columns in A is equal to number of rows in matrix B. So dear students, is very important thing. The condition for multiplication, when we can multiply two matrices, when the product is possible. The product is possible only when number of columns of first matrix is equal to number of rows of second matrix. First matrix का number of columns should be equal to number of rows of second matrix. फर्स्ट मैट्रिक्स में जितना कलम्स रहेंगे सेकेंड मैट्रिक्स में उतना ही रोज रहेंगे. फर्स्ट मैट्रिक्स का जितना कलम्स रहेंगे सेकेंड मैट्रिक्स में उतना ही रोज रहेंगे. मीन्स नंबर ऑफ कलम्स ऑफ फर्स्ट मैट्रिक्स मस्ट बी इक्वल टू नंबर ऑफ रोज. हियर द नंबर ऑफ कलम्स इज n and here the number of rows is n. Then matrix product is possible, otherwise product is not possible. So C is suppose A into B. A is Aij into m cross n into Bjk into of order n cross p. Now C is the product matrix. What is the element? Suppose the element of C is small c. And what is the order of a product matrix? Dear viewers, in case of addition, the addition of two matrices, in case of addition of two matrices, if A and B are of order m cross n, then the sum matrix is of order m cross n. Addition करने के बाद order change नहीं हो रहा था. But here C is the product matrix and the order of the product matrix is, look at here, number of columns is equal to number of rows and the order of a product matrix is m cross p. कॉलम रोज इक्वल हो गए तो रहा क्या, फर्स्ट मैट्रिक्स का रो सेकेंड मैट्रिक्स का कॉलम एंड रो इनटू कॉलम. दिस रो इनटू कॉलम इज द ऑर्डर ऑफ प्रोडक्ट मैट्रिक्स. सो इफ A is a matrix of order m cross n, B is a matrix of order n cross p, then the product matrix is of order m cross p. That means the row of product matrix, the row of product matrix is same as row of first matrix and the column of product matrix is column of second matrix. तो जो product matrix का order होगा इसका number of rows किसके साथ समान होगा, number of rows of first matrix. एंड प्रोडक्ट मैट्रिक्स का नंबर ऑफ कॉलम्स किसके साथ समान होगा, नंबर ऑफ कॉलम्स ऑफ सेकंड मैट्रिक्स. रोज आएंगे फर्स्ट मैट्रिक्स से, कॉलम्स आएंगे सेकंड मैट्रिक्स से. तो हमको क्या पता चला, तो फर्स्ट मैट्रिक्स का रोज मल्टीप्लाई करेंगे सेकंड मैट्रिक्स का कॉलम के साथ. दिस द बेसिक थिंग. जब मल्टीप्लिकेशन होगा फर्स्ट मैट्रिक्स का रो लेंगे सेकंड मैट्रिक्स का कॉलम. फर्स्ट मैट्रिक्स वेरी इंपॉर्टेंट, याद रखो. मल्टीप्लिकेशन जब होगा कैसे होगा, फर्स्ट मैट्रिक्स का रो मल्टीप्लाई होगा किसके साथ, सेकेंड मैट्रिक्स का कॉलम के साथ. बट इन केस ऑफ एडिशन सब्ट्रैक्शन हम जब ऐड कर रहे थे या सब्ट्रैक्ट कर रहे थे, क्या कर रहे थे, करस्पॉन्डिंग एलिमेंट को ऐड कर रहे थे, करस्पॉन्डिंग एलिमेंट को सब्ट्रैक्ट कर रहे थे. बट इन केस ऑफ प्रोडक्ट फर्स्ट एलिमेंट का रो को हम मल्टीप्लाई करेंगे सेकेंड मैट्रिक्स के कॉलम के साथ. याद रहा, फर्स्ट मैट्रिक्स का रो और सेकेंड मैट्रिक्स का कॉलम, फर्स्ट मैट्रिक्स का रो सेकेंड मैट्रिक्स का कॉलम. तो C is the matrix, the product matrix, and the element is C. So we have to multiply the row of first with column of second, row of first, column of second. So row means I, so this is Ci and K. I for row and this I is from first matrix and column from second matrix K. So this is the element of a product matrix. The viewers, matrix product is possible only when number of columns of first matrix is equal to number of rows of second matrix. So the order of a product matrix is number of rows from the first matrix, number of columns from the second matrix. That means m cross p. So you have to multiply rows of first matrix with columns of second matrix. Example, A is a matrix 6, 9, 2, 3 of order 2 cross 2, B is a matrix 2, 6, 0, 7, 9, 8 of order 2 cross 3, and we want to find the value of A into B. That means 6, 9, 2, 3 of order 2 cross 3 into 2, 6, 0, 7, 9, 8 of order 2 cross 3. First check whether the product is possible or not. हमको चेक करना है कि प्रोडक्ट पॉसिबल है कि नहीं. प्रोडक्ट कब पॉसिबल होगा? जब फर्स्ट मैट्रिक्स का नंबर ऑफ कॉलम्स इज इक्वल टू number of rows of second matrix. So here number of columns in the first matrix is 3 and now the example, A is a matrix of order 2 cross 2, B is a matrix of order 2 cross 3. So A into B, we have to find the product of two matrices A and B, but we have to check whether the product is possible or not. हमको पहले टेस्ट करना है कि इस केस में प्रोडक्ट पॉसिबल है कि नहीं. एंड प्रोडक्ट कब पॉसिबल होता है? व्हेन द नंबर ऑफ कॉलम्स ऑफ फर्स्ट मैट्रिक्स इज सेम एज द नंबर ऑफ रोज ऑफ सेकंड मैट्रिक्स. फर्स्ट मैट्रिक्स का कॉलम और सेकंड मैट्रिक्स का रोज समान होना चाहिए. सो लुक एट हियर, the number of columns in the first matrix is 2 and the number of rows in the second matrix is 2. So here number of columns of first matrix, number of rows of second matrix, first matrix का column और second matrix का row equal हो गया. So matrix product is possible, but question arises, what about the number of rows of first matrix and the number of columns of second matrix? ये दोनों इक्वल होंगे कि नहीं? ये दोनों इक्वल होने से या ना होने से प्रोडक्ट का कुछ फर्क नहीं होता है. प्रोडक्ट इज पॉसिबल ओनली व्हेन दिस टू, फर्स्ट द कॉलम ऑफ फर्स्ट मैट्रिक्स द नंबर ऑफ इज इक्वल टू नंबर ऑफ रोज ऑफ सेकंड मैट्रिक्स. दिस इज द ओनली कंडीशन. So now number of columns in the first matrix is equal to number of rows in the second matrix. So product is possible. So how can you multiply? The first thing is, what is the order of a product matrix? Now look at here, dear students, what is the order of a product matrix? The order of a product matrix is, now this column, this row cancelled. What remains? Rows in first matrix, columns in second matrix. So the order of product matrix is 2 cross 3. Row from first matrix, column from second matrix. That means we have to multiply rows of first matrix with columns of second matrix. Rows of first matrix with columns of second matrix. Every row is to be multiplied with every column. हर एक रो को हम हर एक कलम के साथ मल्टीप्लाई करेंगे. सब रो सब कलम के साथ मल्टीप्लाई होगा. Every row will be multiplied with every column. How? Look at here. First, this element is, the order of the matrix is 2 cross 3. The order of the matrix is 2 cross 3 means here this matrix is A11, A12, A13, A21, A22, A23. Like this. This is a simple process to know. A11 means first row, first column. That means you have to multiply first row with first column and write here. This is A12, first row, second column. That means you have to multiply first row with second column and write here. Similarly, this is 1, 3. First row, third column, multiply first row with third column and write here. This is the process of multiplication. So look at here how actually the multiplication occurs. Now is first row, every row is to be multiplied with every column. So first row with first column, first row with first column. Now first row with first column means 6 into 2 plus 9 into 7. So this is the first element of product matrix. First row with first column. Sum of product 6 into 2 plus 9 into 7. Similarly, the second element, first row into second column. You have to multiply first row with second column. How? 6 into 6 plus 9 into 9. Then first row with third column. So first row with third column is 6 into 0 plus 9 into 8. Now first row is multiplied with all columns. As first row was multiplied, all the elements are written in the first row. हम अभी फर्स्ट रो को हर कलम के साथ मल्टीप्लाई कर रहे थे, इसलिए हर एलिमेंट फर्स्ट रो में लिखा गया. नाउ वी हैव टू मल्टीप्लाई सेकेंड रो with all columns. First second row with first column. Second row with first column means 2 into 2 plus 3 into 7. Similarly, second row with second column. Second row with second column is 2 into 6 plus 3 into 9. Then second row with third column, 2 into 0 plus 3 into 8. So solving this, if we solve this, then 6 2 is 12, 9 7 is 63, 6 6 is 36, 9 9 is 81, and you will get the matrix 12 plus 63 75, and this is 117. 72 plus 0 is 72, 21 plus 4 is 25, and this is the product matrix. So this is the way to multiply one matrix with another. That means first row first column, first row second column, first row third column, second row first column, second row second column, second row third column. When first row is multiplied, then you have to write all elements in the first row. When second row is multiplied, then you have to write this all elements in the second row, then simplify to get the answer. But remember one thing, what is the condition for product of two matrices? The condition is that the number of columns for a first matrix should be equal with number of rows of second matrix. फर्स्ट मैट्रिक्स में जितना कलम्स रहेंगे, सेकेंड मैट्रिक्स में उतना रोज रहेंगे, तब जाके मैट्रिक्स प्रोडक्ट इज पॉसिबल. एंड द ऑर्डर ऑफ प्रोडक्ट मैट्रिक्स इज रो फ्रॉम फर्स्ट, कलम फ्रॉम सेकेंड. Now the properties of multiplication of two matrices. So first property is matrix multiplication is not commutative in general. In case of addition क्या हो रहा था कि in case of addition matrix addition was commutative. A plus B is equal to B plus C. But in case of product A into B is not equal to B into A in general. In general the product is not commutative, but may be equal in some cases. But generally the product is not commutative. A into B is not equal to B into A. But only one case is here where the product is commutative, and that case is the matrix multiplication is commutative if two matrices are diagonal matrices of same order. If A and B are two diagonal matrices of same order, then in that case A into B is equal to B into A. That means product is कम्यूटेटिव. सो प्रोडक्ट कब कम्यूटेटिव होगा? जब A एंड B टू डायगोनल मैट्रिक्स होंगे एंड ऑफ सेम ऑर्डर. एंड नेक्स्ट इज मैट्रिक्स मल्टीप्लिकेशन इज एसोसिएटिव. तो दिस ओबेज एसोसिएटिव प्रॉपर्टी मींस A into BC is equal to AB into C. Associative law. Next is the existence of a multiplicative identity. Multiplicative identity means if you multiply identity matrix with A into identity matrix is equal to A, identity matrix into A is also A, where A and I have same order. A is a square matrix, I is a square matrix, and order of these two matrices is same. And the next is the distributive law. A into B plus C is equal to AB plus AC. A plus B into C is AC plus BC is the distributive property. And the last is if you multiply any matrix with a null matrix, then the result will be null matrix. But the order is A is of order m plus and B is of order n plus b. Now number of columns, number of rows same, so the order of the new matrix is m plus b. So the product of null matrix with any matrix is null matrix. So these are the properties of product of two matrices. Now one interesting property which actually exists in case of matrix. In case of numbers, what happens if A into B is equal to 0, then either A is equal to 0 or B is equal to 0. So A is equal to 0 or B is equal to 0. So if A and B, these two are not equal to 0, then A into B cannot be equal to 0. टू नॉन जीरो एलिमेंट्स को मल्टीप्लाई करेंगे तो कभी हम जीरो नंबर नहीं मिलेगा. तो प्रोडक्ट ऑफ टू नॉन जीरो इज नॉन जीरो. The product is 0 means at least one is 0. But in case of matrix, what happens? Here, look at here important thing. 0 matrix is a product of a two non-zero matrix. When two non-zero matrix are multiplied, it may be 0 matrix. May not be 0, but may be 0. Look at here, A is 0, minus 1, 0, 2, B is 3, 5, 0, 0. If we multiply A into B, then we get this, and this is 0 matrix. Look at here, this is not 0 matrix. This is not 0 matrix. 0 matrix means all elements are 0. Here not elements are 0. Here not all elements are 0. So these two are non-zero matrix, but when multiplied, we get 0 matrix. So in matrix, it is possible product of a two non-zero matrix may be 0 matrix.